How to find the inverse of a matrix? When we are asked to find the inverse of a matrix, it's like they're asking us to find the reverse of a matrix. And the formula for finding the inverse of the matrix is 1 over determinant times the adjoint. Now, for us to be able to find the inverse of the matrix, it means that we need to know how we find the determinant of a matrix. Then we also need to know how we find the adjoint of a matrix, so that we are able to substitute it in this expression, 1 over determinant times adjoint, so that we are able to get the inverse. So it means that in this tutorial, we are going to first explore how we get the determinant. Then afterwards, we shall explore how we find the adjoint. And then eventually, we'll be able to find the inverse of a matrix. This is Kisembo Academy, and thanks for tuning in. So let's first explore how do we get the determinant of a matrix. We have an illustration here. If this is a matrix A, B, C, D, and we want to find the determinant of this matrix A, B, C, D, it is as simple as getting the elements in the main diagonal, which is AD, we multiply them, which is this, A times D. Then we also get the elements in the minor diagonal, which is BC. We multiply them, CB, and then we subtract. So now let's look at the two examples that we have here. We are being required to find the determinant of this and the determinant of that matrix. So let's get the determinant of this matrix. To find the determinant of this matrix, we are going to get the elements in the main diagonal. In the main diagonal here, we have 2 and 3. So it's going to be 2 times 3 minus 5 times 1. 2 times 3 is 6 minus 5 times 1, which is 5. So it means the determinant here is 1. Let's get to the next matrix. It's 9 times 4. This is in the main diagonal, so it's going to be 9 times 4 minus 3 times 12. 3 times 12, that is in the minor diagonal. 9 times 4, this is the main diagonal, the major diagonal. So 9 times 4 is 36 minus 3 times 12, which is 36. So the determinant of this matrix is 0. So that is how we find the determinant of a matrix. In finding the adjoint of a matrix, like this one, we have two diagonals. We have the leading diagonal, which is AD. Then we have the minor diagonal, which is CB. So what we do, we go to the leading diagonal and we change the positions. It means that if A is positioned here and D is positioned here, what we are going to do is that in our new adjoint, we are going to put D here and A there. We interchange these positions, we switch them. Then in the minor diagonal, we are going to simply multiply by -1. So it means in this illustration, our adjoint will become, D will go there, so it becomes D here and A here. Then these ones are multiplied by -1, and we will have this turning into -C, and this is -B. And that is our adjoint. Let's do a few examples to illustrate this point. We're having the adjoint of this following, find the adjoint of the following matrices. We have this, so the adjoint of this is going to simply become, we interchange these two numbers in the leading diagonal. So these 3 will come here and the 2 will get here. Then in the minor diagonal, we multiply them by -1. So -1 times 1, that will give us -1, and when you multiply this by -1, gives us -5. So this is the adjoint of that matrix. Let's get to this matrix. The adjoint of this matrix is going to become, we have the 0 here, then the 3, these two interchange, so 3 is down here. Then in this other diagonal, we multiply by -1. So 4 times -1 is -4. Then -1 times -1 gives us +1. And that's the adjoint of this matrix. Let's calculate the adjoint of this matrix. This will become, these interchange their positions. So we have -3 down here, and we have -4 up here, like that. Then in this minor diagonal, we have this 2 times -1 gives us -2, and then -1 times -1 gives us +1. This is the adjoint of that matrix. Then finally, to find this, we interchange these ones, so the 2 comes here, and the 3 goes down here. The 2 comes up here, then the 3 is down here. Then we multiply this by -1, this becomes 2, and this becomes 1. So that's how we find the adjoint of the matrix. So we have just learned how to find the determinant of the matrix. We've also learned how to find the adjoint of the matrix. Now that we know how to find the determinant and the adjoint of the matrix, so it means we can now find the inverse of a matrix. Let's do a few examples as well. We have matrix B, which is 2, 4, -3, -4, and we are required to find the inverse of that matrix. To find the inverse of this matrix, we have to first find the determinant, then we get the adjoint, then afterwards we substitute them in here and get the inverse. So we have matrix B, which is 2, -3, 4, -5. To find the determinant first, the determinant of that matrix is going to be equal to the leading diagonal, which is 2 times -5, minus the minor diagonal, which is 4 times -3. And the answer we shall get here is going to be -10 minus 4 times -3 is -12. So we shall end up with -10 plus 12, and our answer is 2. So 2 is our determinant. So we find the adjoint of the same matrix. Adjoint. The adjoint of that matrix is simply going to become, if we look at the main diagonal, we are going to switch the numbers. So -5 comes here and -2 goes down. So this is going to become -5 up there and 2 down there. And then we multiply this minor diagonal by -1. So -3 times -1 is giving us 3. And 4 times -1 is going to give us -4. And when those two are, so meaning here we have the adjoint. So to get the inverse of this matrix is simple. To get the inverse of this matrix, so it's going to become 1 over determinant. Our determinant is 2. So it's 1 over 2 times our adjoint. Our adjoint is that figure we got there, which is -5, -4, 3, 2. And our answer will simply be, this is a scalar. It's a fraction, but it's a scalar. And we say that when we're multiplying a scalar by a matrix, we multiply that scalar by each element in that matrix. So it means that this is going to be a half times -5, a half times 3, a half times -4, a half times 2. And our answer here will be -5 over 2. A half times -4 is going to give us -2. A half times 3 is going to give us 3 over 2. Then a half times 2 is going to give us 1. And this is the inverse of matrix. Find the inverse of matrix D. Just like we did before, we are going to first find the determinant. Determinant of this matrix is going to be 3 times 6 minus 4 times 5. So 3 times 6 is 18, minus 4 times 5 is 20. And we shall end up with our answer being -2. So that's our determinant. So we get the adjoint of the same matrix. The adjoint of the same matrix is simply going to be, we are going to interchange the elements in the leading diagonal. So we have the 6 coming up here and the 3 coming down here. Then in the minor diagonal, we multiply each element by -1. So -4 times -1 is -4. -5 times -1 is -5. So that becomes our adjoint. So it means that our inverse is going to be equal to 1 over determinant, multiply that by our adjoint. So what we do here, we are going to simply substitute. It's going to become 1 over our determinant, which is negative 2. So the whole thing is 1 over 2, this is negative 2, times our adjoint, which is 6, negative 5, negative 4, 3. And then we shall end up as negative a half times 6 is going to give us negative 3. Negative a half times negative 4 will give us positive 2. Negative a half times negative 5 is giving us positive 5 over 2. The negative a half times 3 will give us negative 3 over 2. And this is the inverse of that matrix. This brings us to the end of this tutorial. Thanks for watching. For more videos, I encourage you to subscribe to this channel and also share on other platforms. I hope you watch the next video. For Kisembo Academy, this is Arnold Ranga Kuramia.